In this lesson, we're going to go over 3 different theorems about one triangle, and then use those theorems to help us answer some questions. All right. So let's start with the first 2 at the top: the triangle longer side theorem and the triangle larger angle theorem. All right. So the triangle longer side theorem states that essentially the largest angle is always going to be opposite the longest side. All right. So the largest angle, right, in a triangle is always opposite the longest side. Okay? And the triangle larger angle theorem is essentially the same idea, that the largest side is always opposite the largest angle. So the largest side is always opposite the largest angle. Now, this is also true for the smallest sides and the smallest angles. So we're focusing on the fact that if you have the largest angle or the largest side, those will be across from each other. But the same thing is true if you're talking about the smallest side and the smallest angle. Okay, now, the other inequality theorem is called the triangle inequality theorem. And this is basically determining, based on your side lengths of your triangle, if you can actually form or create a triangle with those measurements. Okay, so this is where a triangle exists if the sum of the 2 smaller sides is larger than the third side. Okay, so that's kind of the key thing you're looking at when determining if you can actually create a triangle with those 3 side lengths. Okay, so let's use all these theorems and put them into practice with these practice problems. Okay, so the first one, number 1, order the angle measures from least to greatest. Okay, so we're looking at this first triangle, which is triangle ABC, and we want to look at the side lengths to help us determine what's going to be the largest angle and then the smallest one. So when I look at this, the first thing I notice is 13 feet is going to be the longest side. So the angle across from that, angle B, is going to be the greatest angle. So when I finish this, my angle that's going to be the greatest is going to be angle B. My next in order here is going to be 10 feet, and the angle opposite that is angle C. So that's going to be my second largest. And then my smallest one is going to be the 7-foot side length of BC. The angle across from that is angle A. So angle A is going to be the smallest angle all the way up to angle B. All right, and that's kind of the process you're going to do here. So we can do a reverse of that. We'll still do least to greatest, but this time we'll start with the smallest one of 30 inches. So angle T is going to be the smallest one. Then my next largest one is going to be 35 inches, which is angle R. And finally, the largest side length is 38 inches. So angle S, which is across from that, is going to be our largest angle. Oops, sorry about that. All right, so that is 1A and 1B completed. Let's do number 2. All right, very similar idea. Order the side lengths from least to greatest based on these triangles. Now, if you notice in these triangles, we actually only have 2 out of 3 angles. So knowing our understanding from the first semester that all of the angles are going to add up to 180, we can go ahead and figure out that missing one. So we have 82 plus 54, which is 136. So 82 degrees plus 54 degrees is 136. Subtracting that from 180 will give us our angle Z, which is going to be 44 degrees. Okay, now we're able to order the side lengths from least to greatest. The smallest side length is going to be opposite the smallest angle of 44 degrees. So the side length that's opposite that is segment XY. Then the next largest one is 54 degrees. The segment across from that is YZ. And so finally, the largest angle is going to be 82 degrees. So the largest side is going to be across from that, which is XZ. Okay, and that's the process here. Let's do this one here. Triangle EDF, so 103 degrees plus 42 degrees. That's going to be 145 degrees. Subtract that from 180, and you're going to get 35 degrees. Okay, so angle F is 35 degrees. So going with my smallest angle first, that's angle F is my smallest angle. So across from that is segment DE. So that will be the smallest segment. Then we have angle 42 degrees. So across from angle E is going to be segment DF. And then finally, the largest angle is our obtuse angle, 103 degrees. So across from that is segment EF, which will be the longest segment. All right, so that's using those first two theorems in action in 1 and 2. Okay, now using the triangle inequality theorem, we're going to do these next couple. So this next one here, number 3, says to determine if the following side lengths could form a triangle. So remember we said, go back to our notes, that a triangle exists if the sum of the two smaller sides is larger than the third side. So here we go. The two smaller sides are 22 plus 28, which is 50. So I need 50 to be larger than the third side, which is 50. Is 50 larger than 50? No. So these would not be able to form the side lengths of a triangle. Let's do the next one. We have 7 plus 35, which is 42. Is 42 bigger than the third side length of 41? Yes, it is. So we would be able to form a triangle with those side lengths. Okay, now this next question, number 4, is asking us to look at if we have these two sides of a triangle, what are the range of lengths for the third side? So it's really kind of two options here. You could view these questions as saying, okay, these are the two smaller sides, so what does the third larger side have to be? Or you could think of this as we're trying to find the smallest side, and these two are actually the two biggest, and we could use some math to find that as well. So first thing I do is I'm going to do the sum and the difference here of these two. So we have 14 plus 22, which is 36, and we have 22 minus 14, which is 8. So essentially what we're saying is, depending on what kind of triangle we're trying to make, we could have that the largest side, all right, the largest side would have to be less than 36, right? Because if it was more than 36 for that third side, if it was the largest one, it would be more than the sum of the 14 and 22. So it has to be less than 36, but it could also be greater than 8. All right, so those are kind of the range of values for your third side. So it has to be greater than 8, because if it's 7, right, if I do 7 plus 14 is 21, which is not bigger than 22. So it's got to be greater than 8 or less than 36. Those are kind of your two options. Same thing on this one. Part B, we'll do the sum and difference. So 28 plus 31, and we'll do 31 minus 28. So we have 3 when we do subtraction. When we add, we get 59. So your third side could be less than 59 units, or it could be greater than 3 units. So anywhere in between would make this a triangle. Okay? All right, 2 more. All right, gonna get a little bit more challenging here. So we want to graph this triangle B, C, and D. So I'll go ahead and graph that. So 0, 6, 1, 2, 3, 4, 5, 6. This is B. C is 2, negative 5. 1, 2, 3, 4. So that's C. And then D is negative 8, negative 1. 1, 2, 3, 4, 5. So there is D. So let's make this triangle. Okay, so there is my triangle. And we want to figure out the order of the angle measures from least to greatest. Now, we don't know anything about these angles right now. I don't have a protractor. So what I'm going to do is I'm going to use my understanding of the longer angles and sides theorems from the beginning, that if I can find the side lengths of each of these triangles, that will allow me to order the angle measures from least to greatest. So let's find all the side lengths here. So let's do the first one is BC. All right, and we're going to be using the distance formula for all of these, right? That distance formula is the square root of the change in your x squared plus the change in your y squared. Okay, so for this one, for BC, I'm going to have 2 minus 0 squared plus negative 5 minus 6 squared. So that's going to be equal to 2 minus 0 is 2 squared is 4. Negative 5 minus 6 is negative 11. 11 squared is 121. So that equals the square root of 125. Let's do the next one would be CD. So CD, using the distance formula, is going to be negative 8 minus 2 squared plus negative 1 minus negative 5 squared. So that's going to be equal to negative 8 minus 2 is a negative 10, squared is 100, plus negative 1 minus a negative 5 is really adding 5, so that's going to be 4 squared is 16. So the square root of 116 is CD. Let's do the last one, which would be BD. All right, so doing BD would be negative 8 minus 0 squared plus negative 1 minus 6 squared, which is negative 8 squared is 64, plus negative 1 minus 6, that's a negative 7 squared is 49. So that's going to be the square root of, let's see, it should be 113, I believe. Is that right? I think that's right. Yeah, 64 plus 50 is 114, so 1 less is 113. Okay, so in order from our largest side, so BC is our largest side. So opposite BC is going to be our largest angle. So angle D is going to be our largest angle. And then the next largest side is CD. So opposite that is angle B, which means our smallest angle is opposite our smallest side of BD, which is angle C. So that was using the distance formula to find the lengths of these sides, and then using our understanding of those two theorems at the beginning to figure out the order of the angle measures from least to greatest. Okay, last question. We've got a triangle BCD again. We got B, C, and D, and it says order the sides from least to greatest if angle B is 10x minus 28, angle C is 6x minus 1 degrees, and angle D is 8x minus 7 degrees. So I'm going to use my understanding from the first semester that all angles of a triangle add up to 180 degrees. So do 10x minus 28 plus 6x minus 1 plus 8x minus 7 has to be equal to 180 degrees. So let's see, 10x plus 6x, that's 16x, plus 8x is 24x. Adding my other numbers, negative 28 and a negative 1 is negative 29. Negative 29 and negative 7 is negative 36. Let's add that 36 to the other side. When we add that 36 to the other side, we get 216. And I believe if I divide both sides by 24, that's going to be, get my calculator out, 216 divided by 24 is going to be, 9. All right, so x equals 9. So let's go and plug these back in to each of these angles to figure out what they are. So plugging in 9 for this x is going to be, that's 9 times 6 is 54, minus 1 is 53 degrees. Plugging it in here, 9 times 8 is 72, minus 7 is 65 degrees. Plugging in here, that's 90 minus 28. 90 minus 28, which is going to be, let's see, 62 degrees, I believe. Yes, that should be right. Make sure they all add up to 180. Let's see, that's 170. Okay, that should work. All right, great, we're 180. Okay, now, to order the sides from least to greatest, let's start with the smallest angle. The smallest angle is this 53 degrees. So go across the triangle. and the segment that is across angle C is segment BD. Then I'm going to look at the next lowest angle, which is 62 degrees. The side length across from that is segment CD. And finally, that leaves the last one here. 65 degrees is the largest angle. So across from that is going to be BC, which is going to be our last one. Okay, guys, so that is it. That is all the practice questions here. Try the homework questions and come see me if you have any questions. Good luck.